y is equal to e to the power 10 inverse x. Because they have given to us in proof n plus 2th order derivative. Okay. So we have formula of nth order derivative. So before that, to find nth order, we need to find second order or derivative of this. Okay. So let us. So first order, we can write it as y1. We have the symbol also. y1 is equal to e to the power 10 inverse x into, by using chain rule, we have 1 upon 1 plus x square. Got it? By using cross multiplication, we can write it as 1 plus x square into y1. And this is y. So in a seat of this, we can write here y. Okay. Now let us differentiate it again. So first function, differentiation of second function will be y2 plus second function into differentiation of first function will become 2x. And right side we have y1. Got it? Now we can express this 1 plus x square y2 plus 2x y1 minus y1 is equal to 0. So now we can take y1 as a common here. So we have 2x minus 1 into y1 is equal to 0. Now let us differentiate this entire equation n times. Okay, find nth order derivative of this entire equation. And obviously we have product of two function. One is this and second one is this, and here also. So we will use Liebnitz theorem. Okay. So let us find nth order derivative of this. We are finding separately, okay, for both terms. Then we will show put the values. Okay. Let us mention equation 1 here. Because we can do in single step also, but it will be too lengthy. That is why I'm taking separately. 1 plus x square. Obviously, we will take this v because its derivative will become 0 soon, and y2. So nc0, and it will be, because we have differentiated 2 times this y2, and if we are differentiating n times, then it will become yn plus 2 into 1 plus x square. Why? Because un into v. Okay. Nth order derivative of this function and into v plus nc1 n plus 1. Because in next step, we take n minus 1th order derivative because we differentiate 2 times already. If we differentiate n minus 1 times, so obviously we will have n plus 1 times. Got it? And derivative of this v1, first order derivative of v, this is 2x plus nc2 yn means n minus 2th order derivative is yn, because plus 2 and n minus 2 will cancel, then we will get yn. And second order derivative of this will become 2 only. Now let us simplify them. So nc0 is 1 and into 1 plus x square into y n plus 2. And NC1 is n. And we have 2x also here. So let us take it as 2nx into yn plus 1 plus NC2 is n into n minus 1 over 2, and we have to this here into 2 and yn. So finally we have 1 plus x square into yn plus 2 plus 2nx yn plus 1 and plus n into n minus 1 yn. Okay. This is nth order derivative of first term of this given equation. Now let us find its derivative. Okay. Nth order derivative of second term. Let us find it. 2x minus 1 into yn. Okay. So dn over dxn of 2. Okay, I'm just checking. Yes. 2x minus 1. Okay. Into y1. So first function, sorry, because we are finding nth order derivative and C0, and its nth order derivative will become yn plus 1 into v is 2x minus 1 plus nc1 yn, because n minus 1 third order derivative of yn will become, sorry, yn, not n minus. So yn. Are you getting me? And its derivative will become 2. And after that, obviously, we will get 0. So let us simplify. This is 1 into yn plus 1 into 2x minus 1. It will become n. And we have 2 also and yn. And we can write it as 2x minus 1 into yn plus 1 and plus 2 n in yn. So now let us put values. We can mention this equation 2 and equation 3. And we can mention, that is, put values from equation second and third in equation first. So let us put 1 plus x square into yn plus 2. Okay. 1 plus x square into yn plus 2 plus 2nx into yn plus 1. And the last term is n into n minus 1 into yn. Okay. N into and next term in equation. Okay, second. Now we are putting value of this, which is 2x minus 1 into yn plus 1. 2x minus 1 into yn plus 1. And next is next is 2n yn. Okay. 2n yn. Okay. Plus 2n yn is equal to 0. Now let us take common whatever we have. Yn plus 1, and here also we have yn plus 1. Let us take this common. So inside we have 2nx plus 2x minus 1, and we have yn plus 1. Okay, and what we need to prove, let me check it. And plus n into n minus 1 plus 2n into yn is equal to 0. So let us simplify more. 1 plus x square yn plus 2 and plus we can take here x as a common because here we have a 2x and here we have 2nx. So let us take x as a common, or we can take 2 also because they have given to us 2n plus 2 as. So we can take accordingly 2n plus 2 and take here x as a common minus 1 into yn plus 1 plus n square minus n plus 2n yn is equal to 0. So 2n minus n we have n. Then we can take n as a common, then inside we have n plus 1. Are you getting me? If you got, then we can write in single step. Otherwise, I can explain you using one more step. Okay, if you go. So here we can take n into n plus 1. Yn is equal to 0. Proved. Got it? So you got this Liebnitz theorem and how to do questions? You got each and every step? Whenever you have like yn plus 1th order derivative, so just differentiate one time, then use nth order derivative formula or Leibniz theorem, whatever we need. And if you need yn plus 2 order derivative, just differentiate 2 times first, then use nth order derivative, either Leibniz theorem or directly whatever we need. Okay. So in this way, you can solve this type of questions or prove them. Okay. Good. Anything else you want to ask? Okay, all the best.